A bag holds 1,000 coins. 999 of them are perfectly ordinary, a head on one face and a tail on the other. One of them is not. That one has heads on both faces, so it cannot land tails at all. You reach into the bag without looking and take a single coin out. You flip it 10 times and it comes up heads 10 times running. Everything you need is already on the table. 1,000 coins, one of them two-headed, and 10 heads in a row. So here is the question. The coin sitting in your hand, how likely is it that you are holding the two-headed one? Most people answer that in about 2 seconds, and most of them are a long way off. There are two answers people give here, and the interesting part is that they fail in opposite directions. The first one is instant. An ordinary coin lands heads 10 times, running about once in 1,000 tries. And to be exact, once in 1,024. That essentially never happens to anybody. So the coin is rigged, obviously, and there is barely a question to answer. The second answer comes from somebody who has already been caught out by the first. They say, "Careful, you only had one chance in 1,000 of pulling the two-headed coin out of that bag to begin with. So the answer is 1 in 1,000. Now look at what each of those quietly throws away. The first answer never once looks at the bag. The second answer never once looks at the flips. Half the problem each, and the real answer is not standing on either side of the room. So let us be exact about the two things we actually know, because everything after this is bookkeeping. The first is the bag. Before you flip anything, before you know a single thing about how the coin behaves, the chance that you are holding the two-headed one is 1 in 1,000. That number has a name, and the name is the prior. It is the number you would have quoted while the coin was still in the bag. The second thing is what 10 flips can do. An ordinary coin flipped 10 times writes down a pattern. Heads, tails, tails, heads, and so on, 10 symbols long. 2 ways for each flip, 10 flips, so 2 multiplied by itself 10 times. That is 1,024 possible patterns, and every one of them is equally likely. Exactly one of those patterns is 10 heads. The two-headed coin has no such menu. It cannot land tails, so whatever it does, the pattern you write down is 10 heads every single time. 2 coins, 2 completely different ways of producing the same piece of evidence. That is the whole problem. This problem is not really testing arithmetic. Plenty of people watching will reach the right final number and still walk out of the room without an offer, because the number was never the thing being scored. What was being scored is whether the small number stayed in view when the big one arrived. I have coached hundreds of people through these rounds, and for some of them it ended in the desk they were aiming at, north of 500,000 a year. Not because they knew more, because they narrated the move. The Quant interview playbook is built around that. 281 worked problems, each one modeled out loud before it is solved. Link is in the description. Now, back to those 1,000 coins. Here is the move that settles it, and there is no algebra anywhere in it. Instead of asking how probable each story is, count how many ways each story could have produced what you saw. Give every one of the 1,000 coins its own list of 1,024 patterns. Because the coin was drawn blind, every coin is equally likely. So all of those pairings of a coin with a pattern are equally likely too. Now, walk through them and keep only the ones that show 10 heads. The two-headed coin keeps all 1,024 of its patterns, because for that coin, every pattern is 10 heads. An ordinary coin keeps exactly 1, the single all-heads pattern, out of its 1,024. and there are 999 ordinary coins, so between them, they keep 999. There they are, side by side. 1,024 ways for the trick coin, 999 ways for the honest ones. 2 bars drawn to scale, and you can barely tell which is taller. And what we have just done has a name. Every probability from here on is a probability given that the coin came up heads 10 times. And a probability like that one is called a conditional probability. Written down, it looks like this. P, open bracket, 2-headed, then a vertical bar, then 10 heads, close bracket. The P in front is read as the probability that. The bar in the middle is read out loud as given that. So the whole line says, the probability that the coin is 2-headed, given that it came up heads 10 times. So add them up. 1,024 ways plus 999 ways is 2,023 ways in total for 10 heads to have happened at all. And 1,024 of those 2,023 have the 2-headed coin sitting in your hand. So the answer is 1,024 over 2,023. As a decimal, 0.506, just over a half. Not almost certainly rigged, not 1 in 1,000. A coin flip leaning very slightly towards the trick coin. Which is the honest way to say it. After 10 heads in a row, you still cannot tell the two stories apart. The evidence really was strong. The coin really was rare. And the two of them very nearly cancel. That answer is more fragile than it looks, and it is worth seeing how fragile. Nothing in the argument says 10 is special. So change the number of heads and watch the picture move. Every extra head doubles the count on the 2-headed side, while the 999 on the ordinary side never moves at all. The whole story is one number doubling against a fixed wall. At 9 heads, the trick coin has 512 ways against 999. That is about a third. 9 heads in a row, and the ordinary explanation is still comfortably ahead. At 10 heads, it is 1,024 against 999, and it tips over. One extra flip carries it across the line. After that, it climbs, but slowly. You need 14 heads before you are past 90%. And now the part that makes this problem a small joke at your expense. It lands on a coin flip only because 1,024 happens to sit right next to 1,000. Put 1,025 coins in the bag instead, and the answer is exactly a half. Dead on, no rounding. Put 100 coins in the bag, and 10 heads make the trick coin a near certainty. So the crossing point is not a fact about coins, it is a fact about the size of the bag. One last thing, because it is the habit underneath the answer, rather than the answer itself. Both wrong answers were built the same way, by throwing one of the two numbers in the bin. Rigged throws away the bag. 1 in 1,000 throws away the flips. The right answer keeps both of them on the table and lets them argue. And the reason it lands where it lands is that they turned out to be very evenly matched. That is what a desk is actually watching for here. Not whether you can raise 2 to the 10th, whether the small number is still in your hand when the big one turns up. Which is the part almost nobody rehearses. I have spent more than 15 years recruiting in finance, on the side of the table where the decision gets made. And in a real room, the scoring starts long before the final number. Whether you said what you were assuming, whether you recovered when a path died. Most candidates never see that sheet. Inside the Quant interview playbook, there are 4 full mock interviews with the scoring rubric running down the margin. So you read what was being written while the candidate was still talking. Link is in the description. Study the rubric before your next live round. 1,000 coins, 10 heads, still a coin flip.